Today, we are pleased to have our strategic partner, Glastonbury Gage, and renowned industry expert Mike Rose show you how to properly use tri-rolls.
Hello, I'm Mike Rose, your screw thread guru and senior thread engineer with Glastonbury Southern Gage, an old company, old school, but we do make the most of today's technology to manufacture the very best gauges and gauging for product screw threads. We also manufacture a lot of other artifacts, fixtures, and precision masters used to control the quality and size of product being manufactured out there. Now today we're going to be showing you a tri-roll. This is a tri-roll. Got 3 rolls on it, hooked to a frame. It's got an indicator, a base. It's used to very quickly inspect product threads. You simply put the product thread in, read on the indicator what it checks. This instrument here, the tri-roll, it checks an external product thread and their features. Now this is a very important part of this. Let me explain. Within our system, within our standards, the ASME B1.3 has 3 levels of acceptability for screw threads: level 21, level 22, and level 23. Level 21 is the functional acceptance of screw threads. It simply uses go and no-go fixed limit gauges. If a screw will go into a go ring, it's functionally in size at the maximum material limit. If it will not go into a no-go ring, it's functionally in size at the minimum material limit. This does not necessarily, though, mean that that thread is in size at all aspects or all points on it. Level 22 and level 23 require that all elements of the thread be in tolerance. Level 22 allows you to use a go gauge. You cannot be out of tolerance at a single point at your maximum material limit if it will go into a go gauge. However, the minimum material limit, the functional size of an external thread, is larger than a single element. So level 22 requires that you be within size at all aspects of this thread. You can use a go ring, but you have to check the pitch diameter at a single point with level 22. Level 23 does not allow the use of functional gauges at all, at least not functional fixed limit gauges. You have to measure those aspects. You have to take a measurement of the functional size as well as a single element size. Those then are compared. This is a tolerance dimension within the standards. You need to see the ASME B1.1 for that. The tri-roll is used for levels 22 and 23, but can also be used to qualify for level 21 as it is easy to use. Now let's look at the assembly. The basic assembly has a frame. You notice this logo's black here. We had older models up here. It had the green labels on them. They're all the same units. There's no difference. It's just different label on them, different plate on the side of it. You have an indicator, which is where you read your size. You have the base that you mount the frame to. You got 3 rolls down here and a stop adjustment tool. There are many ways to assemble a tri-roll. In fact, part of this will come to you already assembled. But you can set the tension spring, you can assemble the frame, you can put the rolls on it, set the master, set your stop, put the indicator on. But today we're going to be showing you this, each component, to explain them to you so you get a better understanding of what you're doing and better able you to set one of these up. First, let's look at the frame. There's a hole in the frame that you can see here. This is put a screw through that attaches it to the base. That's really easy little feature to put together. At the very top then, as you see here, we have a universal mount for your indicators. It's got a screw in the side of it that you can put the indicator in and tighten this in place. Then we also have a tension screw. This tension screw is in the very bottom of the frame here. There's a big spring in there that pushes against the lever arm on this here. If you turn that clockwise, it'll tighten the tension on that, so it makes it a little harder to hold it up and down. It gives you a better grab onto your product thread. If you're doing a lot of products today, though, you might want to back it off a little bit so it doesn't wear out your thumb quite as much. Now, these will come to you already set. As a rule, you don't normally have to set those. Next, let's look at the stop adjustment. This little area up on top of it here, as you see here, this has got a screw in it the stop screw, which presses against the lever arm and prevents movement of this lever arm. It's also got a lock collet that'll lock the whole thing in place. With your indicator in place, you can adjust this so that you see the indicator movement, then back it off a turn or two to give you 30 seconds or so of actual movement on the indicator. You get about a 30 second per turn with this. Now, what this does, it prevents the lever arm with all the tension on it from damaging the indicator. Now, how do you do the adjustment? This is a stop adjustment tool, two-piece construction here. You see up here by our diagram. This has two components on it. One is a lock driver. This actually is used to open or close the lock nut, which holds everything in place. You can break that loose with this part of the tool here. You see it's got little flanges on it, which fits into this. Then you have a screwdriver in this also that is used to index the stop screw up and down. So by loosening the lock screw, screwing this down against the lever arm, or backing it off, whatever you need to do with this, then you can lock it back in place and you have your stop is set at that. Now that's your basic frame components. Next, what we're going to look at though is the frames come with spindles on them. These spindles here you see is what you slide the rolls on and hold them in place. The spindles on these are three-piece components. They have the spindle itself. It goes through the holes that's in the frames here that you see we had. And you have a lock nut on the back there, a spindle nut that locks this in place. And you have another little screw that goes in the other side. That actually holds the roll in place. So you put the spindle in, you lock the nut on it, then you put the roll on and lock it in place with the retaining screw. As long as we're talking about the spindles, let's go ahead and mount a roll on this. The rolls they have numbers on them, 1, 2, and 3. By placing the number 1 roll on the outside spindle over here, and the number 2 roll at the top, and the number 3 roll at the inside, that gives you checking for a right-handed thread. If you reverse that order so that you have 1, 2, and 3, you can check a left-hand thread. Now, like I just showed you, slip the roll onto that, numbers out, slip the little retaining screw into this at this point, and what we're going to do is just pull that up. And what we're going to do now is you got to be very careful about this because you don't want to get it too tight, but you got to pull it up properly. Pull it up till the roll will not roll, and you back it off about a 1/16 a turn so that roll will roll. Now that is proper at that point. Now, let's look at the rolls. This is a major part of what we're doing here with these. You have what we call a type 3 roll, which is a functional roll. It has several ribs on it, and it sits on several threads of your product thread. Now this will pick up the actual size of that thread, plus it will pick up the diametrical effect of the lead flank angles in that thread. This will always be the largest reading of your thread. Next now, let's look at the single element rolls. We have basically two types. One is a cone and V, which is basically that. We have a V that sits on the ridge of a thread, and we have a cone that sits down into the valley of a thread. This picks up the true pitch diameter. It's a single element check. We talked about earlier, System 22 requires you make this check on a product. The other type we have is a radius. It has a radius on the rolls simulating a best wire. And when that sits on there, this also picks up the true pitch diameter, but this one picks it up without any effect whatsoever from the flank angle variations. This will be your smallest reading. The difference in this reading and the functional reading we have up here is the diametrical effect of the lead and flank angle variations within that product. This is toleranced. See the B1.1 from the amount of tolerance you allow for those two to be different. This is the smallest reading, and the difference is the total of lead and flank variations. We also have full profile rolls. We don't see a lot of those. I don't think a lot of people really understand what they are. But by the use of this set of rolls here and a combination of these others, you can tell how much of your variation in there is due to lead or the flank angle, effects of the flank angles. The difference between the readings and the functional reading is the diametrical effect of the lead. And we have the major diameter rolls for checking the major of the product and a minor diameter rolls checking a minor. This has the flank angles cut back so it only seats in the minor. Now this is very important if you're checking a UNR thread, and especially so if you're checking the UNJ thread. So let's see what we've got. We have a screw at the side. We've hooked the frame to the base with. You can also get these drilled for aluminum handles if you want a handheld. Most people use them with a base. We have the 3 rolls in place. They rotate, move, and they're in clockwise motion here for a right-hand thread, 1, 2, and 3. Indicators in place. We've set our stop adjusting tool back here. So now all that's really left is to set the indicator. But with this, we will take a master. This is a master. These masters come certified. It will tell on that certification how much this master deviates from 0. That's very important. You put this into the frame, set it up, and you move it so you get it seated firmly. Now, this particular master we look at on the certification said it checks -0.2 from true 0. So what we want to do is move this indicator to where it's got -0.2 on it. Loosen the little screw at the top for this, move it up to a -2. Now, this has been set up so that we're actually going to be checking parts from true 0, not just from a known master. Now, if we fail to answer any of your questions about this, you can call our 1-800 number. One of our technicians will be glad to help you. And we'd like to thank you for viewing our videos and being with us today.